Ladies and gentlemen, look at here. We're in day 2 of installing our AXIS Dyno. We've got a 950 up on the stand, baby. We got it up on the drum, lined up. We're about to make some pulls with it. We're doing some training with the one and only Mark Dobeck with Dobeck Performance, the creator of this dyno that is specialized just for any machine with a CVT. Got a ton of footage from yesterday, and I'm going to be dropping that in here as well. We had the cforce 600 on it yesterday, training on it. We've got our dyno hooked up. This is going to be forcing all the wind through from the drum itself. We're going to pull some numbers. You excited?
Yep.
All right, baby. Look, we're just doing some training today on it and getting used to it, and we're going to make some pulls, see what we can do.
Okay, and so now, and so you want this even with this. Day that will always repeat itself on a dyno. So when you do your clutch testing, this is the standard you'd use because the customer could be doing all types of things with it. Okay, once you know what you like, we have a dirty blower that goes in here. By putting this on the shaft, it's not encased like your typical, blowers would be. It's just sitting in the breeze. So it becomes, we call it dirty blower because it acts like mud or sand. So if you have a guy that his entire racing is just dropping into the mud pit and going across, 100 feet, well, that's what we put on here. So that as he looks at it, as you study his clutching, you would do it with a dirty blower. Okay, and then we have another group with the UTVs that run paddle tires. So then they put their dyno tires on and run the dirty blower to achieve. And so then the understanding the difference between what the customer's seeing and what you get on a dyno is much closer to each other. This drum is very light, right? And then there's a shaft going through the middle. Unlike any other dyno, our shaft and our drum is free from each other. You can just spin. You can hold that shaft still and spin the drum. The only thing that connects the two is a spoke. One spoke. That one spoke is right there. Okay? So that spoke is a bathroom scale or a fish scale. When you push this around, that scale has to pull the shaft around. And we grab our measurement at that point. Just doing this, that load cell, just as if you were touching a bathroom scale. Okay, so we get our torque number. The way it's mounted, it's like 9 inches from the center. So then we have to add, the extra inches to make up to get 1 foot arm. okay? And so when you hit this, we get that data, okay? So that's torque, and then the other thing we need is movement. We need speed. And so this is a brand new update. Like I said, you're the first install I'm doing of this. The wires come in from the load cell right here, and then they exit right here, color for color. And it sits there and passes that load cell through. These two dynos are the first two going out with this. And then the other three wires here in the center, that's our speed, that's an encoder. And it's all built in, one unit. It's expensive, American made. And so that's one of the reasons why I wanted to come down and play with this. There's only two forces acting on all of our vehicles. It has to move its own weight and its occupants, and it has to push some air out of the way. The fact of the matter is, we all know that if you did 150 and a quarter mile, and you wanted to go 5 more miles per hour and a quarter, it's not going to be just 5 more horse. You're going to need a bunch of horse.
That's
well,
right.
So that scales all the way down to where 0 to 50, you could have literally 2 horse and maybe get a mile per hour. Think of it when you're doing slow speeds, the majority of a dyno from 0 to 50 is all about the inertia. It's moving its own weight because air is not a factor. So that's where the inertia discs, are playing the biggest part. Okay? So we adjusted inertia plates. So this, when we accelerate on the dyno, it has to push its own weight. It has to accelerate those discs, and it has to push that air. That is at a cost. You could have one of your central heating buddies in town. He will come over here with a manometer, a device that he checks the balance of ventilators and buildings. And he could put a hole in this tube, and by knowing the diameter, 8-inch, and the pressure that's in there, he could tell what kind of power is going out through there. Okay, he could determine the airflow. Okay, so all of this all ties together. So when we accelerate, that load cell that's right here, it's the only device, right, that's measuring what the tire is having to accelerate. This weight and that blow, that movement of air. So what we did then is take that load cell number, which is foot-pounds, and we bring it over here into this software program. Right here, when you go in this toolbox up here, this is the data. So there's your load cell. Okay, and we're going to just plug this in. And so now we get a green patch here, and there's your load cell. We zero it just before you step on a bathroom scale. You lean over to make sure you're not, it's legit, right? You're not a pork chop. So we're going to hit 0, and then the rest of the data is ready to go. Okay, so then we'll just go back to opening this program up. So this is your main screen. So go ahead and everything, I said a mechanic did this. I made the mistake of listening to Highline engineers in my life. Any of you guys watch this? and they created this masterpiece in Windows, and with all these pull down menus and stuff. Well, it cost me money to train individuals over the year how to use software. So, just you guys can just start walking through it right now. Okay. So again, especially with CVT clutches, you can imagine what's going on there as those weights and all that stuff shift. It's paramount that you sit there and get a routine. I'm helping you. I'm getting you. I'm taking, like you're gonna do a quarter-mile run, you nudge up there, and you get your lights, and then you move a little forward, bang, okay? So that's what this does. So once you're set there and you're offloaded, your clutches are sitting there, then the minute it touches, you were delayed, okay? So you can't quite see that, but so the minute they touch, we're recording, so you want to get your timing down, so then you whack it. Dyno torque is as measured, right there at that load cell. I mean, you understand how that load cell's in there, and you understand the force that we put holding that load cell. So when you hit it, that's the force we're actually measuring that you're putting to the ground. When we first started the chassis dynamometer, the Dynojet dyno in 1990, it was a fixed drum that we just accelerate, right? When we accelerate that, we get a horsepower number. So to get torque, you have to hook up, you need RPM, right? So you then would connect to the magneto, the coil, or when it came into vogue, injectors. So you could connect to one of those and get an RPM reading, and so then horsepower formula is complete in giving you torque. But it's torque at the engine minus the driveline, right? So you got horsepower and you got torque. And the torque number is what everybody uses in all the magazines, what everybody talks about. And I don't know how you're gonna, but I have a problem with that. Just simply because if it was torque minus the driveline, if I lower the tire pressure, my horsepower would go down and my torque would go down. But my torque shouldn't go down because I'm taking a reading right from the engine. So therefore, engine torque, as we defined it for years, not really, it's a number. It's a good number. We all used it. I'll give you another scenario. If you take two Harleys, two 883s, you and I are on them, we do a roll on, same, right? No matter what we do, same. We put them on a dyno, they read, 58 horse and, probably 40, 45 foot-pounds of torque. Great. So we put them on a dynamometer, okay? Not this one, other dynos. And we run them, we see that number. So now we're gonna take and change the front sprocket. Of course, I think on early ones, 883s, it could be a sprocket. Otherwise, they have belts now. So we change a shiv on it. So we change the gearing. Now when you and I race, I'm pulling away from you every time we hit because I got a different sprocket, right? I got a better mechanical advantage, okay? Now I'm gonna scrub off some top speed. But we're not racing, we're in the town here. I'm gonna race you down Main Street. We then bring that bike that just beats your bike and put on a dyno here. It reads 58, same, right? Well, it should, but it just beat another one.
All right.
If you were truly wanted to learn something about what's really going on in the world, you'd like to know why that guy just beat me. So let's step up. I'm gonna go, why don't you spend 100 grand on an engine dyno? Okay? So now we got I won't mention any names. We got a nice 100 grand test cell here, okay? And somebody brings in one of your CFMOTOs, and he says, this thing flat kicks everybody's butt. It's unbelievable, but I don't know what's in it. Some guy did it, and he's dead. And I want you to figure out what's in this. So you put it on the dyno, your engine dyno, and you run it, and it shows 150 horse, okay? So many torque. But what you didn't know, and what that $100,000 dyno didn't find out, is that the entire engine, the crank and everything was lightened up. So every time you jumped out of throttle, this thing just ripped through your clutch and just accelerated. But, so here's two types of dynos out there that can't even read major performance issues in the industry, right? I mean, the simplest mod that someone makes is to put a countershaft sprocket up, right, on their motocross bike area. Now they can wheelie, okay? No one can touch them hanging on block to block, but we can't measure it. So that was one of my pet peeves, because I've got tagged on it in my career, and I didn't have an answer for the guy. So what we went to do with the AXIS dyno is we want to see that absolute force being put down without any bias. So you've got to understand, if that's a 2,000 pound drum, well, the clutch acts differently. So it's going to stay in first gear longer, and essentially in its tall gear, and give you a different number. So to really understand what's being put to the ground, you have to do it exactly how we did it. There's only a certain force that's going to be held back, and then we're going to get right in between. And if you have a big heavy drum, well then energy, Newton's law says, if you're going to advance that weight, it's going to cost you energy. Mm-hmm. And as that thing speeds up, or the acceleration of it slows down, it costs you less energy. Well, how do you want me to calculate that? Well, now I have to put in inertia number based on acceleration. When, cheapers, guys, all we had to do is this.
Load cell.
Just put a load cell in and make sure that the load cell is only influenced by the exact vehicle weight and exact air. Now you can start seeing things. You have ECUs to this day tied up to gearboxes that can read first, second, third, fourth. You can actually program different gears. You can't take a heavy drum and put it in first gear. You can't get any traction. But when the tire is asked, as it is in the AXIS dyno, to only accelerate its own weight, the tire's fine. Okay? So this can go deeper and deeper, but we'll get back to some tuning.
All right, more training. I'll get you some footage here in just a moment when we do some more learning, but we're just learning how to do this with Mark and
So right now,
get it all set up just right, testing everything, the electronics, the plug-ins, the software, and get where we can use this thing, put it to good use.
110, it's just a calibration number.
To 50? You running it up to 50? Alright. We're checking our AFRs and looking at speed and changes. That was without the airbox cover on. We're going to label that in the software. And what we're doing, this is just training purposes. We're testing to set up the software correctly and getting everything lined up. so that we can start doing some very advanced tuning with our CVT clutches, our clutch kits, tuning the AFRs, your air to fuel ratio, and any performance parts that we do here at Main Street Cycle using this AXIS Dyno. This thing is awesome. Alright, making a couple of test pulls. This AXIS Dyno is absolutely amazing. It's the only one truly designed to really be able to modify and tune and see what your clutches are doing and your AFR and just all kinds of stuff that you can do for a CVT that we'll be able to graph and see and make changes to optimize the torque curve, optimize the when the RPMs are really hitting to keep that peak power. And you're going to see that in a ton of new videos coming up. But we want to get this curve. I'll go over here, hold on. Oh, by the way, so we're not really pushing right now the machine to peak power at the moment because while we're doing is setting up. This is Joel's laptop for the shop. Just setting up all the software from Mark Dobeck's computer. And just getting all of our systems set up. We've been getting trained by the best in the business and learning a ton of stuff that's even helping us with the CFMOTOs, with our clutches, with our tuning, and just going to optimize it. And man, going to be so good for all the future of Main Street Cycle with CFMOTO performance parts and upgrades. And we're going to talk about, you know, the real horsepower versus you know, what's posted and advertised. Y'all know all about CVT, how the CVT uses up like 15% of the horsepower, all your drive line. You have all that to consider. Some people are asking about how, you know, will our dyno be able to simulate real world stuff? And yes, there's a system inside of here that we can make changes to. That's why this handle is here. There is a fan that produces what they term as the dirty fan, the dirty air, and it simulates heavy mud riding, dropping off in a mud pit and just hammering it. Also sand bogging down. This is going to simulate all those things, as well as us changing out the weights. These are weight plates, and you put a certain amount of weight depending upon the machine and the conditions that like your load, your fully packed out load. If you're trying to tune it and you're carrying a bunch of gear, we'll be able to do that inside of this system. You can only get this kind of setup with the AXIS Dyno. I love the tie down system on this as well. This is one of a kind, patent to hold it securely. We strap this down to simulate the weight and all from riders, the squat that you'll have, and so you get that set up with your tires on the drum. And this is the best of the best for what we do with the CVTs. If anybody has a CVT driven machine, which is just about everything but a Honda, this is the dyno to run it on. We got this one custom built here for Main Street Cycle, and Mark Dobeck of Dobeck Performance. You'll see him in the video, already have probably. But this man is one of the most intelligent men I've ever sat and listened to. He's been in this business for many years with his history with, he created Dynojet, and just if you've seen Dobeck Performance, that's him, and he's been here for a while, a few days. We're only in coming to the end of day 2, and he's going to be here for a couple more days training all the mechanics. And Joel's been learning a lot, and he's already the man when it comes to CFMOTOs. But wow, loads of information that we've been learning so that we can optimize these CFMOTOs across the lineup, the four-wheelers, utility machines, and the sport side-by-sides. Man, when it comes to clutch tuning, for your different tires, for different scenarios, different riding conditions, we're going to be able to simulate that by changing the fan and doing different things there. And it's going to be able to give us real-world data. You know, I know that, you know, how we've been gauging this is by the seat of the pants, you know, out there on the trails, and that's important, right? That's what the customer feels, and but that's going to correlate to here on these graphs as we're able to check the dyno torque, which is the torque applied to the drum from the tires. We're going to be able to look at AFR, your air to fuel ratio, you know, checking our engine RPMs. There's a lot of hookups we have to do to make all that happen, but we're getting in a lot of data, and we're going to be able to do some great tuning with it as well. Clutches, we'll be able to see what exhaust does. We'll be able to make all these changes. We'll even be able to prove other setups that people claim work. We'll put them to the test and be able to compare them to each run. And now we're going to have nothing but facts, and it's going to be good stuff, ain't it?